In our previous construction video, we used our compass and straight edge in order to create ourselves an isosceles triangle based on the definition of an isosceles triangle where you have at least two congruent sides, right? Then we investigated our triangle and were able to discover if these two sides are congruent to each other. Then the angles that are opposite them, which we call the base angles, are also congruent to each other, right? And so what we want to do is investigate in this video the converse of that, that if we start with congruent base angles, does that make these two sides congruent to each other? Does it create an isosceles triangle? So let's get ourselves a new piece of paper here. And this time I'm going to start with my base. So just take your straight edge, make your base, sort of like that. All right, and then I'm just going to choose an acute angle size for this particular base angle. And I'll put a B over here, excuse me. And now I do have to have this thing be an acute angle. And the reason why I do is because if it was, let's say, a right angle, you could probably visualize pretty easily that this thing would not close off and make a triangle. Looks like it's on the verge of being, say, a rectangle or something like that. And then it's even worse if these things were obtuse angles. It'll never, ever close. Okay, so what I want to do is use my compass here and do the best that I can copying this angle at C over here at B. All right, so to do such a thing, I'm going to take a compass setting and we're going to make an arc that intersects both sides of this angle. Put the point of your compass in C, make an arc to intersect both sides. Flip your compass around, put the point on B, do the same exact arc, just going in the opposite direction. Okay, and just so that it's easy to refer to each of these points, I'll call each one an X and a Y. All right, so obviously this point is X prime. Y prime is going to be on this new arc someplace. In order to see where that's going to be, we'll use our compass and we will stretch it from X to Y. So here's where the accuracy comes in. The more accurate that you make this step, the better your construction's gonna be. I think it's about as good as it's gonna get. All right, I'm gonna put the point of my compass into X prime, make an arc right there on the larger one. And pro tip, book yourself a little hole right there. And then that point should be our Y prime. Okay, so I'll use my straight edge now and connect that Y prime back to point B. Okay. All right, so here then, where these things intersect, that should be my point A, and then here we have our triangle, which is possibly isosceles. So one way to do this, of course, is if I had a piece of padded paper, I could trace this thing off and flip it over. Another way to do it is, I guess, I could, say, measure each one of these sides and check to see if those two segments were congruent. But the way I'm gonna do it is actually just with a compass. I'm going to stretch my compass from A to C. Hopefully this stretches that far. These bow compasses are pretty fantastic until you have to stretch it to a particular length. Okay, so there we go. We can see that here is the length of AC. And now let's flip it over to the other side and check to see if AB is also that same exact length. And it does look like it is. So this is at least investigative proof, inductive proof that, or evidence, I should say, that the converse of the Base Angles Theorem seems to be true. That if we start with congruent angles, that it seems to make two congruent sides, an isosceles triangle. Let's make sure that you can see that fine. Maybe even flip this thing around. Just like that, and do a little focus job.